Hello, everyone, and welcome to another episode of Astronomy Answered Simply. Today's question is kind of in line with some of the ones I've answered previously. How does the sun not burn up all of its hydrogen and subsequent fused elements almost instantaneously? The sun is literally on fire 100% of the time, fusing hydrogen to helium, helium to carbon, etc. How does it not burn up all at once? Well, this is a great question because you're wanting to understand. So the first thing you need to understand is that the sun does not burn. Not at all. Even though it looks like a giant ball of burning gas in the sky, it is not. Burning is a chemical reaction. Chemical reactions change chemical compounds and typically release molecules that were bound up via one form or another and release energy in the process. Nuclear fusion is what happens in the center of stars. Fusion is the merger of two atoms. So let's do a quick demonstration. Chemistry would be atoms like this that undergo a chemical reaction and get broken apart and release energy in that process, known as an exothermic reaction. Nuclear fusion would be inside the center of stars is because the enormous temperature and pressure of the stars is driving the atoms of hydrogen and helium closer and closer and closer until they're in the center of the core or near the core of the star. The immense pressure and the immense gravity and the immense conditions actually push past the electromagnetic forces of the electrons trying to repel each other, and they fuse together. The two protons and the neutrons inside them fuse into one larger atom, larger molecule, or larger element. That process releases enormous amounts of energy. Excuse me. Now that energy is what keeps the star from having runaway fusion and gravity from taking over. So a star is kind of a balancing act between the forces of gravity and the energy released from nuclear fusion. The energy released pushes, let's make my nose the core. I mean, it's a big target. So if we have gravity pulling hundreds and billions of tons of hydrogen all to this point, well, the force of the energy that's released pushes outward on the gravity trying to collapse. So you have kind of a nice balancing act that's fairly stable for billions of years in a sun the size of our star. Or a star the size of our sun. Excuse me. I'm only halfway through my coffee this morning. So that balance is what prevents everything from happening very, very, very quickly. Now, larger mass stars, like supergiant stars, the kind that end up in supernova, their lifespan is only 10s or 15s or 20 million years. And these are the most massive stars. They fuse extremely fast, and they burn, or they consume or fuse their elements very, very quickly and release massive amounts of energy. But because they are so massive, the force of gravity is much, much, much stronger and much, much, much denser, and they fuse those elements faster and faster and faster, so their lifespan is much shorter than our star. Our star has sufficient mass to create fusion, but not enough that it takes over and it lasts for a very long time. That's good for us because we were allowed to evolve on this planet, and now we are here speculating about how it happens, what it is, why we're here, all these existential weirdness. That's another question for another time. Now, back to the original. So It does not burn. It cannot burn all at once because the fusion only happens in the core, and it takes time for that material and that energy to work its way in and out. The light that hits us, let me give you a little example. So the light from the sun that I just opened my window, that giant big bright ball over there, that light left the core of the sun somewhere between 100 and 300,000 years ago. Yes, literally the same photons that are hitting us right now were emitted by the fusion of hydrogen to helium hundreds of thousands of years ago. Freaky. The sun is so dense, so thick, that it takes those photons, the energy, hundreds of thousands of years to work its way to the surface. Once it gets to the surface of the sun, it's emitted as light waves. It gets to us in 8 minutes, maybe 8.5, but it's roughly 8 minutes. That's really fast. But space has no atmosphere, so it's just traveling very, very quickly at the speed of light. So that's how stars do not burn up all their fuel instantly. I have a couple of other videos on previous Quora questions I've answered, or you can see it on my YouTube channel, about stars and black holes. And keep asking me questions because I love explaining and I want you to learn. And I'm glad you asked this because it allows me to help you break some misconceptions and understand astronomy a little better. The universe is a fascinating place. I'm happy to help you explore it. My name's John. Like, subscribe, and keep asking questions. Thanks and have a great day.